we go for lesson 11. So 11.A is on circles, but it really just goes over, oh, you can't see that, really just goes over some vocabulary and a little reminder. And no matter how I write that, it looks like my... So first things first, they cover that half a circle. If this is my diameter, then this would be a semicircle. And then they cover what a major and minor arc are. So if this is the center, minor arc is less than 180 degrees. So there would be a minor arc. So this would be a minor arc. And then the opposite of that would be a major arc. Okay, and that would be something that is greater. So that would be a major arc. So that is 11.A is just going over some vocabulary. This would literally be half a circle, but instead of calling it half a circle, they call it a semicircle. All right, so 11.B reviews the properties of circles. So the first property, and I'm going to kind of cover it as we do a problem in it. So I'm just going to jump right in and review the property as we do the problem. So if I have, if I intercept this circle, with 2, there we go. So I'm going to label this A, this B, this P, this R. So I know that angle A must be congruent to angle B because they intersect the same arc, which is in this case PR. So I don't know if you can see that, but angle A goes to arc PR, and so does angle B if you trace it back. Okay? Now, remember they're talking about those two angles. So I know that angle A, and so let's just say that's 30 degrees, that must be congruent to angle B, which I'm going to tell you is y plus 20. Okay, so there are those two, and we'll solve it in a second. So as something else I know that angle P is congruent to angle R because they intersect the same angle. Same arc, I apologize. Which in this case is AB. So notice both of these, the little curvature above it, it kind of looks like an arc, so that's how I know this is talking about the arc, where this is the symbol for angle. So let's say angle P is 46 degrees, and this angle here is x plus 10 degrees. So solve for x and y. So I know that 30 degrees must equal y plus 20, so y equals 10. And I know that 46 degrees must equal x plus 10, so x equals 36. Okay? And again, that is because they intersect the same arc. So angle P intercepts angle AB, and so does angle AR. So they share that side where A and B share the other side. So that's one of the review properties. That's from geometry, properties of circles. So we're going to try another one. And this one, I'm going to try to recreate the drawing that I drew at home. I'm going to inscribe a quadrilateral inside this circle. And notice it touches the edge of the circle. So I've drawn a quadrilateral. I'm going to label this up here as Z. I'm going to label this here 50. And I'm going to label this 75, X, Y, and this is 80 degrees. So they're saying arc Z, that's Z, and they're saying this arc here is 50. All right, and they would like me to solve for X, Y, and Z. Now, another property of circles, the sum of interior angles in a quadrilateral equal 360 degrees. Now that's a review of geometry. Remember, it's the number of sides minus 1 times 180. So anyways, that's how I have that. Or sorry, number of sides minus 2 times 180. But a triangle, the sum of a triangle is 180. Know that the sum of a quadrilateral is 360. Another property here that they're going to go over is that an arc is 2 times the inscribed angle. Okay, so I'm going to use this information to solve for X, Y, and Z. So it doesn't really matter what we start with, but I'm going to set it up this way. I know that angle 80 intercepts the arc Z plus 50. Okay, so I know that 2 times 80 must equal Z plus 50. Okay, so the inscribed angle is 80, but if you look at it is touching the arc of Z all the way to 50, and so that's why I wrote Z plus 50. Okay, so angle 80 is touching this whole arc, and I know 2 times the arc must equal 2 times the inscribed angle. So 160 equals Z plus 50, so Z equals 130 degrees. Okay. Now I'm going to solve X and Y. So I know another fact is I know that the sum of opposite angles in a quadrilateral equal 180 degrees. So here are 3 review principles about circles. So I know that 80 plus X must equal 180 degrees because these are opposite angles. So if that means that X would be 100, and that means that Y plus 75 equals 180, so Y would equal 105 degrees. So I use this second property that I've gone over to solve for a Z, and the bottom to solve for XY. All right, moving on, I'm going to do another one with you, kind of reviewing this material. I can't turn the page in my notebook. So number 3, again, I'm going to draw a large circle, but this time I'm going to inscribe a triangle. And I'm going to label this arc here Z degrees, X degrees, Y degrees. This is 75, and up here is 35 degrees. All right, so they would like me to solve for X, Y, and Z. Now I'm going to just start with x. So I know that this inscribed angle here of 75 has to do with this arc of x. And review earlier was 2 times the inscribed angle must equal x. So that means that 150 degrees equals x. The same must be true for y. If I look down here, I know that y shares the inscribed angle of 35. So 2 times 35 would equal y. So 70 degrees equals y. Now how to solve for z? Z is very simple, right? An entire circle equals 360 degrees. So 360 minus x, which is 150, minus 70 will equal z. So if I subtract that, I will get the value of z. So 360 minus 150 minus 70 should give me z. So that leaves me with, if I subtract those out, I get z equals 140 degrees. All right, moving on in section 11, we're going to do 2 more involving circles, just so you've seen everything that could possibly be thrown at you in homework. So the next property, if I have 2 chords, and I know that this is 15, and this right here is x plus 10, this here is x plus 5, and this is 20. So here is another property of circles. The products of the segments of the chords are equal. So 15 times x plus 10 must equal 20 times x plus 5. Okay, so that's how you would set that problem up. Then you would distribute, so 15x plus 150 equals 20x plus 100. So that would give me 50 equals 5x, so x equals 10. Number 5, so the last property is a shape that is circumscribed across a shape, across a circle. Wow, I just really butchered that. So here is a circle, and then let's say I'm going to form a triangle on the outside. All right, so when that is the case, I know that it's intersecting here, here, and here. Okay. The next property is a circle is tangent at all 3 points. Then the pieces must be congruent. So this piece must equal this piece, and this must equal this, and this. In fact, hold on. I should have used dots because I need tick marks for this final. So I know this must equal that. So if I told you that this is x plus 4, and this is x plus y, this is 10, and this is 6, and this is x and x. I know that x plus 4 is congruent to 6, and I know x plus y is congruent to 10. So those are my 2 statements. I know these must be equal, and I know that these must be equal. So this here would tell me that x equals 2. So that means 2 plus y equals 10, so y equals 8. It's not too bad once you do it. The last part of lesson 11 reviews the quadratic formula. Which, if you don't remember, I'm going to write it really large here. X equals a negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And this works for a quadratic in standard form. And that's where you're getting your a, b, and c. So I'm only going to do one, but I'm going to have to turn the page in order to do that problem. Or maybe I'll do two of them. We'll see. We'll see. And how to write their answers. So I'm going to say we're on example 6. So solve 3x squared minus 2x plus 5 equals 0. So x equals a negative b plus or minus b squared minus 4 times a times c all over 2 times a. So I'm going to simplify that. That gives me 2 plus or minus 4 minus, I got negative 56. All over 6. And then I'm going to simplify that. So 56 is 4 times 14. So that would give me 2 plus or minus 2i root 14 all over 6. And then I'm going to reduce. So x equals 1/3 plus or minus. They wrote it two ways, 14 over 3i. So I have to reduce by 2. And this is my final answer. So one more and then we'll be done. Solve 2x squared plus 1x plus 7 equals 0. So x equals a negative b plus or minus the square root of, b squared minus 4 times a times c all over 2 times a. We're going to simplify that. So negative 1 plus or minus the square root. And I got, 1 minus 4 times 2 times 7. I got negative 55 all over 4. Okay. So from here, that gives me x equals negative 1/4 plus or minus the square root of 55 over 4i. 55 is just 5 times 11, and I cannot simplify. But the negative gives me I. Okay, and that is it for section 11. You are going to skip quite a few. You're going to skip numbers 4, 8, 19 through 21, 25, 30, and I think I add one more. 20, I should have put 24. I put these out of order. I apologize. 24 and 27. So you're skipping quite a bit of from this lesson. You're welcome.